All right, this is your last video of Math 50. It is called Putting It All Together. So this is using your, what do we know so far? So for a right triangle, we have Pythagorean theorem, and we have SOHCAHTOA, which is our three trig ratios. For non-right angle triangles, so we'll just draw one that's not right, okay? We have the sine law, which we use when we have an angle across from a side. Or we have the cosine law, which we only use when we don't have an angle across from a side, and we have two scenarios. SAS means we can solve for a side, or side, side, side means we can solve for any angle. Okay. The important thing about the cosine law is that you can only solve for the side across from that sandwiched angle. Okay, so these are the tools we have at our disposal. And here's a question that we're going to use it in. So this says solve for x to the nearest tenth. So we can see that x is in a right triangle, okay, this one here, but the only thing we know in that right triangle is a 45 degrees. We also can see that angle, our side x is in a giant right angle triangle, and we know this 30 degrees, but we don't know this whole side length here. So we can't get into this right triangle yet. So we must have to do something in the non-right angle triangle so that we can solve for a side in the right angle triangle that we can use. So I can see that we know this length here, and we know this angle. And so my guess is that we are going to want to solve for this side here. Now to do that, we have to have a known angle across from a known side. I don't have it. What about cosine law? Do I have SAS? No. So what am I going to do? Well, there's a couple other rules that we haven't talked about for maybe a long time or ever in this course, and that's these rules: supplementary, and complementary. Complementary. Supplementary angles are angles on a line. So if I have two angles, these angles add up to 180 degrees. Okay, this is sort of assumed knowledge. Complementary is that if you have two angles in a 90-degree angle, that they will add up to 90 degrees. Okay, so this is some background information that you need to be able to know to maybe solve these questions. But what that means is that we can solve for this angle in here. Okay, this angle in here, I would do 180 degrees minus 45 degrees. And if I plug that into my calculator, I don't need a calculator, it's 35, but 135. But when we plug it into our calculator, we get 135 degrees. So now I can put that known piece of information in here. I can say this is 135 degrees. Well, I still don't have a known angle across from a known side because I don't know this side across here. But once I know all or two angles in a triangle, I can always find the third. So now I'm going to do 180 degrees minus the 30 degrees minus the 135 degrees. Sometimes you have to do a little bit of detective work before you can get to where you want to go. So minus 30 minus 135 is equal to 15 degrees. So now I know that this angle up here is 15 degrees. Now some people have a hard time seeing these triangles when they're pushed together. So feel free, if you want to, you can always kind of do a drawing of the two triangles. So we've got this one, we know this is 30, we know this is 135, we know this is 15, and we know this is 100. So if it helps you to kind of redraw just that one part of the triangle, you can feel free to do that. But what it was is that we wanted to solve for this. So it's important to know which side you're going to solve for. Actually, I called it y. So y in this side. So we want to solve for this side across from this angle. And now we have a known angle across from a known side. So I'm solving for y. Y is a side. So I'm going to set the sine law. Y is across from the sine of 30, just like 100 is across from the sine of 15. So hopefully you remember how to solve this one. We're going to solve for y. We're going to multiply both sides by sine 30. I don't know why sometimes the screen glitches and other times it doesn't. Okay, divided by the sine of 15. And then we're going to plug this into our calculator. So we've got 100 times the sine of 30 equals divided by the sine of 15 equals. That gives us, now we're going to use this answer again, so keep it all, 193.1851653. Maybe at this point, store it as A, up to you, or it can just be an answer button in your calculator. Okay, but now we know this side here. So maybe we want to go through, so this was step, what did we solve for first here? We solved for this, then we solved for this, then we solve for this. And now the next thing we're going to solve for is in this right triangle. So let's draw that right triangle. We know this is 45. We now know side y is 193.1851653. Okay, and so now they're asking us to solve for x. So how do you solve a right angle triangle? Well, step one, you label your sides. Okay, always start with your hypotenuse, which is across from the 90-degree angle, and then across from the angle in question. So we know this is 45, so this is going to be our opposite, this is going to be our adjacent. We have a known hypotenuse and an unknown opposite. So we have O and H, which means we're going to use sine. So then we set up our trig ratio. We set it up as the sine of 45 is equal to the opposite, which is x, over the hypotenuse, which is 193.1851653. To solve for x, you're going to take this number here and you're going to multiply it. So you've got 193.1851653 times the sine of 45, and you hit equals. So now this is still in my calculator, so I'm just going to hit times, because then it's going to take that previous answer and times it by the sine of 45. And that gives me to the nearest 10th. Is that what it said to answer to? To the nearest 10th. I can now round because this is a final answer. That gives me an answer of 136.6. Now I always want to check to see if there's units. There is, meters. So meters. Awesome. And that is tying together everything that we've learned in trig. Well, not necessarily, you didn't do the cosine law, but it tied together your non-right angle triangle and your right triangle knowledge together into one question. All right, good luck. You've got this.